All right, let's continue. We've got 3 more graphs that we're going to do now. Let's jump in. Let's start with f of x equals the absolute value of x. Now we're going to make a table of values again. I am going to pick some different values than what I normally pick. I'm going to pick -8, -4, -2, 0, 1, 3, 5, and 8. I'm picking kind of some random numbers, but I would like some numbers that are a little bit further away from 0 this time, and you'll see why in just a moment. So let's figure out the corresponding y values. This function takes the absolute value of the input, so the absolute value of -8 is +8. The absolute value of -4 is +4. The absolute value of -2 is +2. The absolute value of 0 is 0. And then the absolute value of a positive number is just that number itself. So we've got 1, 3, 5, and 8. Let's get an xy plane and let's look at this graph. The first point is -8, 8. So that's to the left 8 and then up 8. That is going to be right about here. Then we've got -4, 4. It's to the left 4 and up 4. That is going to be right here. We've got -2, 2. It's going to go right there. We've got the origin 0, 0. And then 1, 1, 3, 3, 5, 5, and then 8, 8. What sort of shape does this look like? Well, it ends up being kind of like a letter V, only with a 90-degree angle, a right angle in between at that vertex. So this is the graph of f of x equals the absolute value of x. You'll notice that it doesn't go below the x-axis. And the reason for that, there's no negative y values, because when we take the absolute value of something, we cannot end up with a negative. That's why we've got nothing down here. All right, let's do 2 more. The next one, g of x equals 3. All right, let's make a table of values. I'm going to pick some x values. Let's do -10, -5, 0, 1, 5, and 7. I'm just picking random numbers here, numbers that I know are going to be on our graph, because we don't want to pick anything that's larger than 12 or less than -12. Anyways, in this case, the function g of x just returns 3 as the output. Doesn't matter what x is, doesn't matter what the input is, the output is always going to be 3. So for all of these, the output, or the function value, is going to end up being 3. Let's see what this looks like. All right, let's plot these points. -10, 3 is there. -5, 3, 0, 3, 1, 3, 5, 3, 7, 3. All of these points have a y value of 3, and so our graph is actually going to be a horizontal line that has height 3. This is a constant function. It means the function value is a constant number, and always a constant function is going to give you a horizontal line whose y value is equal to the constant. So this is, g of x equals 3. And there we go. All right, one final function that we're going to look at. This is going to have a little bit more complexity than we've seen before. H of x equals 1 over x. All right. So let's pick some x values. I am going to pick 1, 2, 3, 4, and 10. Then we're going to pick 0, and then -1, -2, -4, and -10. However, we're going to end up picking even more values later. This is a more complicated graph, and so it's really important that we've got a lot of values so that we can figure out what this graph is going to look like. But let's start plugging in values here. If x is 1, 1 over 1 is just 1. If x is 2, 1 divided by 2 is 1/2, but I'm going to write that as 0.5. I think decimal approximations might be a little bit easier for us to compare with. If x is 3, that gives us 1 over 3. 1/3 is about 0.3. I'm doing approximations here, and that's fine for graphs. We don't need these points to be exact because we're not robots that can actually tell the difference between 0.3 and 0.333. All right, if x is 4, then we've got 1/4, which is 0.25. And when x is 10, we've got 1/10, which is 0.1. Now, if we try and plug in 0 for x, 1 divided by 0 is undefined. So we're not going to have any points that have an x value of 0. Now, with the negative values, we're going to have basically the same values as we had before for the positives, but a positive divided by a negative ends up being a negative. So here we're going to have -1, -0.5, -0.25, and -0.1. Now I'm going to pull up an XY plane so we can start graphing this, but we are going to end up getting some more points to help us figure out what the graph looks like. I know this is gigantic compared to the other XY planes that I've drawn, but I really think it's important that we do a good job with this graph. So let's start plotting our points. 1, 1 is right here. 2, 0.5 is going to be right there. 3, 0.3 is about there. 4, 0.25 is right about there. 10, 0.1, that's barely over the x-axis, just barely, 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 barely. And if we look at what's going on in this part of the graph, we end up getting a smooth curve that's getting smaller and smaller and smaller, closer and closer to the x-axis. Oops. But it's never actually going to go below the x-axis. It's never going to dip down here as we move to the right. And the reason is, the larger the x value we have, the larger the denominator, the smaller the fraction's going to be, but it's never going to be negative because a positive divided by a positive will always be positive. So as we go to the right, the y values are getting smaller and smaller and smaller and smaller, but we are never going to go below the x-axis. All right, now let's plot some more of these points. We've got some negative ones. We've got -1, -1, -2, -0.5, -4, -0.25, -10, -0.1. And we're seeing a similar sort of thing over here as we move to the left, except we're below the x-axis instead of above it. All right, now we need to figure out what's going on in the middle here. Is this going to connect? Is it going to be kind of like a heartbeat monitor, like beep, 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 you know, hopefully that made you laugh. Or what's going to happen? And there is one thing that we know. When x is 0, y is undefined. So we are not going to have any points on the y-axis. So these two are not actually going to be able to connect up. There's going to be a gap along the y-axis. But what happens in between those two parts? Well, let's make a few more values. What I want to do now is I want to pick x to be 1/2 and I'm going to pick x equals 1/5. I'm also going to pick -1/2 and -1/5. Now, if x is 1/2, then our function becomes 1 divided by 1/2. And we know that if we divide by a fraction, it's the same as multiplying by the reciprocal. So that's going to be 1 times 2 over 1, which gives us 2. So when x is 1/2, y is going to be 2, and that gives us this point right here. Now when x is 1/5, this is going to be 1 divided by 1/5. We know that we can change this to a multiplication by writing it as 1 times 5 over 1, and that gives us 5. So we end up with 1/5 comma 5, which is going to be right about here. And in fact, as we move to the left, we go up, 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 steeper, 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 steeper. And we've got a similar thing happening here where we're getting closer and closer to the y-axis, but we're never going to cross it or touch it. Now, if we've got -1/2, this is going to be 1 divided by -1/2, which is the same as 1 times -2 over 1, which is -2. So we've got -1/2, -2, which we can plot right there. And it's probably not a surprise when we plug in -1/5, we're going to end up with -5. That's going to be down here. And we're going to have the same sort of a situation down here, just on the left-hand side of the axis. Now this is the graph of h of x equals 1 over x. It's an important graph that we're going to see in the future multiple times, but I want to look at something here, specifically what's happening with the x-axis and the y-axis. The graph is getting closer and closer to the x-axis, but it never crosses it, and it never actually ends up touching it either. Now, my drawings are not perfect. I am not a robot, and the width of the curve is not 0. There's some width to these curves. So eventually, the width of the curve that I'm drawing is actually going to be bigger than the distance between the curve and the axis. So that's a bit of a problem. It's a bit of a flaw just with graphing things. But we also have the same sort of a thing with the y-axis. The graph is getting closer and closer to it and never touching it and never crossing it. And we have a name for that, actually. That is called an asymptote, which I will write out for you right now. This is an asymptote. A-S-Y-M-P-T-O-T-E. An asymptote is a line that the graph is getting closer and closer to and never touching and never crossing. Now, we're going to see this later on in the semester, and we're going to be focused on it a lot more then, but I did just want to point it out now because I think this is the first graph that we've seen where there is an asymptote. So it's really good for you to pay a little bit of attention to that.